The last section of this chapter is 6.8. Now 6.8 talks about graphing absolute value functions. Now we've actually done that, but we're going to go into more detail. You should remember that a graph of an absolute value function is going to look like a V. It is a V-shaped graph that either points upward or downward. So a V-shaped graph that points upward or downward is the graph of an absolute value function or equation. In lesson 5.3, you graphed absolute value equations by making tables of values. In this lesson, you are going to graph by translating the graph of y equals the absolute value of x. Now remember, this is your parent function. A translation is a shift of a graph horizontally, vertically, or both. The result is a graph of the same shape and size, but in a different position. So example number 1. These are vertical translations. Vertical translation, so look at the first graph. This is your parent function. Now, how did you do this before? You graphed this using a t-table. So you would plug in 1 and get 1. Plug in 2, the absolute value of 2 is 2. Plug in 3, the absolute value of 3 is 3. Plug in -1. The absolute value of -1 is 1. -2, 2. -3, 3. So you would graph this using a t-table. Now look at this graph. Y equals the absolute value of x plus 2. How does this one differ from this one? I don't want you to see it's like shorter. This is the same width here. This one doesn't look as wide though because the arrows are not drawn as long, but it's still the same. This angle measure here would be the same as the angle measure here. So how are they the same? How are they different? Hopefully you notice this. The graphs are the exact same shape. In this first equation, the y-intercept is at 0, 0. Here, it's at 0, 2. That's the only thing that's different. So what has happened to your graph? It's gone up 1. I'm sorry, it's gone up 2. So look at this. The plus 2 tells you how far up your graph went. Now I'm not sure why they did not put this in a key concept, but I think you should make note of this. The graph of y equals absolute value of x plus k is a translation. K is a positive integer, therefore the graph goes up k units. So this is plus 2. The entire graph goes up plus 2. If it was negative k, then the graph is going to go down. So for example, if this is plus 2, the graph goes up 2. If this is minus 5, the graph goes down 5. If this is minus a half, the graph goes down a half. And it goes down a half from your original parent value. So this, I want you to make note. This right here, the plus k, the k tells you to go how many units to go up or how many units to go down if it is negative. Now in example number 2, we have y equals the absolute value of x minus 1. So you would start with your original parent function, your parent graph, which is indicated here in black. And because there's a minus 1 at the end, your graph is going to go down 1 unit. Now, if you still wanted to do a t-table, and you could plug in -3, -2, -1, 0, 1, 2, 3, you absolutely can. And I still encourage you to do that. But if you plug that in, the absolute value of -3 is 3 minus 1 is 2. This one would be 1, this would become 0, this would become 1, this would become... Nope, that's not 1, that's -1. This becomes 0, this becomes 1, this becomes 2. And if you graphed all these points, -3, 2, -2, 1, -1, 0, 0, -1, and so on, you would find out that you could get the same graph by using a t-table. But if you graph your parent function and then just take it down 1, then it would work. So example number 3. we're just going to write an absolute value equation knowing that in A, it goes 8 units down, and in B, it goes 6 units up. So in A, you would have y equals the absolute value of x. It goes down 8 units, so it would be minus 8. Y equals the absolute value of x. It goes 6 units up, so you would go plus 6. That's it. Now the following tables of values show graphs and show what would happen when you graph two equations. Now I'm just going to graph these for you. Now I'm going to graph y equals x minus 3 in the absolute value, and y equals the absolute value of x plus 3. So first I'm going to make a table of values for each. So if I plug in, let's just do negative 2. Negative 2. That gives you negative 2 minus 3 is negative 5. The absolute value of negative 5 is 5. Negative 1, 0, 1, 2, 3, 4, 5. And the reason why I'm keep going is because if you notice a pattern as you go along, like negative 1 minus 3, this is going to give you 4. 3, 2, 1, 0. You have to find when it's going to bounce back up because it's a V. So if you plug in 4, that gives you 1 and 2. Notice it's symmetric. It's starting to go back up. This is going to be your vertex right there because everything else is going to go up as the same as the other side. So in the y equals the absolute value of x plus 3, I'm once again just going to plug in some values. But you'll notice when I plug this in, again, negative 2 plus 3 is 1. This gives me 1. This gives me 2. This gives me 3, 4, 5. Notice that I don't have that bounce back point. When does it start going back up? Well, it's going to be over here this way. So I'm going to pick some other values. Negative 3, negative 4. This gives me 0. This gives me 1. This gives me 2. Now if I graphed both of these, I'm going to graph this first one in blue. So the first one in blue, if I graphed all these points, negative 2, 5, negative 1, 4, and so on, it'd look like this. Now I'm going to graph the second one in red. Negative 2, 1, negative 1, 2. If I graphed all of these, now if you graph this one, it'd look like that. Now your parent function, remember, is right in the middle. I'm going to put that in purple. This is your parent function. So what is the relationship from the blue one, which is our first one, to your parent function? Notice that it's gone to the right. So this one has gone to the right 3 units. But your red one has gone to the left 3 units, 1, 2, 3, from your parent function. So it's backwards. If you have a minus 3, that actually means you're going to the right 3 spaces. If you have a plus 3, you're actually going to go left 3 spaces. So if it is inside the absolute value, it's the opposite. But you're going to go either right or left. So, for a positive number, x plus h, that means it goes h units left. If it's minus h, it actually goes h units right. So I want you to write this. This is your main transformation, I guess you would call it, equation based on absolute value functions. Now, they should have written this in the book, but they didn't. And maybe we'll do it later. But this is what it looks like. Your parent function, remember, is just this. So you have 3 things here. You have an a value, which is the number in front. You have an h value. And you have a k value. Now your h and k value, might get a little confusing, but we'll get to this later on. hk is the vertex of your absolute value function. Now your A value tells you how wide or narrow your graph gets. In addition, if it's negative A, the graph is upside down. It faces downward. The H value tells you to go right or left, and it's opposite. If it's a negative H, you go right. If it's a positive H, you go left. And K, if it's positive, tells you to go up. Negative tells you to go down. So in example 4, here's what it says. If I take my parent function, which is always the black line, inside says +2, that means my entire graph shifts left 2 spaces. If I go to the right 2, it'll say -2 inside. Now something we haven't talked about here is domain and range. Now I'm just going to mark domain and range here. Domain for all of these, since you'll notice the arrows go left or right, your domain is all real numbers, but your range is not. If you look at this problem, what's the lowest y value up or down that we go? It's 0. There is nothing below the x-axis here. So there's nothing in the negatives on the y. And that's true for both of them. So here, your y value is anything that is greater than or equal to 0. And it's actually the same on both of these. For example, write an equation for each translation. In this one, we would have y equals x, and we go x 8 units left, so that'd be x plus 8, the absolute value of x plus 8. And in B, we go 6 units right, so it'd be the absolute value of x minus 6. In the last example, we're going to actually write an equation based on a graph. Now, while your book doesn't get this hard yet, I figured it'd be fun to have some fun here. We should have some fun in doing some more challenging problems. So just look at this. What do you think your equation would be for the blue absolute value graph and the red? Well, the first thing I look at, now I'm not going to actually go wider or narrower today. So you'll notice the blue graph though does what? It's upside down. Therefore we know it's negative. So we have a value that we have to plug in here after the x that tells you to go right or left, and a number after the absolute value that tells you to go up or down. So you'll notice, how many spaces left does this go? This goes 2 spaces left. So do I put -2 or +2 inside the absolute value? It's the opposite, so I plug in +2. The vertex here is -2, 4. So you actually plug in -2 for h. And remember my formula I told you? Oops. This value right here, h, is -2. Well, minus -2 gives you +2. The plus k, which is 4, is going to be +4. This means that your graph is upside down. It goes left 2 spaces and up 4. So try to do the red graph on your own. What do you think it's going to be? Y equals what? Hopefully you figure out it's going to be the absolute value of x minus 5 minus 3. Since we go right 5, down 3, that means it's -5, -5, and then -3 since it goes down 3. Let's also just find the domain and range of each of these. So the domain on both of them is going to be x is all real numbers because the arrows both go both directions. They can be any number going to the right, any number going to the left. Now the range, however, is not that way. Let's look at the blue one. The values of y must be what? Well, here's 4. You'll notice they're not above 4. So that means all your values for the range on the first one have to be less than, this should be dots here, y equals anything that is less than or equal to 4. Now your range on the red, what are your y values? They're everything that's greater than or equal to negative 3, which is right here. Everything is above negative 3.